Okay, so for the next three, we're going to find the inverse, and that's pretty much it. So we'll start off, again, so we're looking for the inverse of this function right here. So we start off by changing the a of r to just a. Our goal is to solve for r, because remember that's the variable, not pi. Pi is a number. So we're dividing by pi. So then that's going to give us a over pi is r squared. So now we take the square root of both sides. And normally we would put a plus minus right here because we don't know, this r could be negative or positive. When you square it, you can't, it's still positive. So usually we put a plus or minus here. But because this is a real life application problem, these variables are all positive. Okay, so then we have, I'll just leave r on the left side, square root of a over pi, and then we just write it in the proper notation, which is r of a equals square root of a over pi. So we're writing the radius in terms of the area. So this would be the final answer. This would be the inverse. Okay, so we're looking for the inverse of this function. This is the surface area of a sphere. Okay, so just like before, we're going to switch out the a of r to just a. 4/3 pi r cubed. I can multiply both sides by 3/4. And so the 3/4 and 4/3 on the right side becomes 1. And then I can divide by pi. Remember, dividing by pi is the same thing as multiplying by 1 over pi, right? So I could put 1 over pi here. So then that's going to give me 3a, because 1 times 3 is 3, and 4 pi equals r cubed. So to leave r by itself, we do the cube root of both sides. So that leaves r equals cube root of 3a over 4 pi. So now we just write it in proper notation, which is r of a equals cube root of 3a over 4 pi. So we're writing the radius of the sphere in terms of its surface area. So if you know the area, the surface area of the sphere, you can calculate the radius with this function, with the inverse function. Okay, for this third one, we're looking for the inverse of this function right here. Okay, so we start off by, so this is the average depth in feet of the water over which a tsunami travels, where S is the speed in miles per hour. Okay, so S is the speed and D is the depth of the water, average depth. So we're going to write D equals 1 over 14.9 is cubed. So we're going to multiply both sides by 14.9. So I'll put parentheses instead. And so 14.9 on the left side also. So on the right side, the 14.9 becomes 1 because it cancels out. And so you're left with 14.9d equals s cubed. So now we take the cube root of both sides. So then it gives me s equals s equals cube root of 14.9d. So in proper notation, it would be s of d is the cube root of 14.9d. So if you knew the depth of the water in feet, you can calculate the speed with this function, with the inverse function. Whereas with the original function, if you knew the speed of the tsunami, you can calculate the depth, the average depth of water in feet. Okay, so each one serves its purpose. Alright, so for number 2, I've set up a table with the values for A, starting with 20, going up to 100, and going up by 20 feet, square feet. So that's because that's what they asked you to do right here. Okay, from 20 to 100, every 20 feet squared. And so I've set up the table with all the values that you need. So now it's just using the calculator. When you do the first one, you get 11.8885, but we're going to round it off to 12. For 40, we're going to have 19. For 60, it's 24.98, so we're going to put 25. For 80, it's going to be 29.777, so we're going to put 30. And then for the last one, you don't even need a calculator. Square root of 100 is 10. 10 times 4 is 40. 40 minus 6 is 34. So now we're going to plot these points. So it's a square root function, so it has to have that shape. 20 goes to 12. So notice the vertical axis, this one right here, is going up by 4. And the horizontal axis is going by 10. So 10 square feet, and then 4 feet of fence length right here. So 2012 would be right here. 4019 would be just past 20, so about here. 6025 would be about here. And 8030. So 28. So 8030 would be halfway between right there in the middle of that square. And then 134. So 134 would go right in the middle of that square right there. And so we connect it. Oops, I missed that one. Like that. Okay, and so that's it for that one. Okay, so for 3, I did the same thing. I set it up. T is your independent variable because it's the one here inside the function, and then R is your dependent variable. This is like your Y, and this is like your X right there. It gave you the values to choose for the time right here, to use for a time. And so I went ahead and set it up. So all I have to do is punch it into the calculator. Well, the first one's pretty easy. Anything times 0 is 0, so you don't need a calculator for that. The next one is 1 times 100. That's 100 divided by pi, and then we take the square root of that, and that gives us 5.6. The next one is 200, because 2 times 100 is 200. 200 divided by pi, and then you take the square root of that. That gives you 7.98, so I would call that an 8. For the next one, 300 divided by pi, and then you take the square root of that. That's 9.77, so I'll call that 9.8. And then for the last one, 4 times 100 is 400 divided by pi. Then you find that out and take the square root of that, and you get 11.3. And so notice over here the horizontal axis is by half hour, right? Because it's that first tick mark is 30 minutes, and then the next is 1 hour. On the vertical axis, every tick mark is 2 meters, so 2, 4, 6, 8. So we're going to go ahead and plot 0, 0, 1, 5.6, so it's closer to 6, right? So 4, 6 about here, and then 2, 8, and then 3, 9.8, it's almost 10. And 4, 11.3. So 4, this is 10, 11, about here. Okay, and connect. And there's the arrow to go to the right, but I don't know if there's a limit on time. so we'll just put it like that. Okay, for number 4, I chose these p-values because that's what it's telling you right here. These are intervals, they're not ordered pairs. So it's saying from p is 0 to p is 60, from the p-value 60 to 120, from 120 to 180. So these are intervals right here. Okay, the intervals that you'll see right here, that you see here, the same numbers. When you input the numbers into your calculator, some calculators have the key, okay, and so all you would have to do is 15.2 times that key, and then the number, you know, like the 0, the 60, the 120, the 180. If your calculator doesn't have that key, then it probably has the key right below it. Like the ones we have in class have this key. So here are the steps. So you'd put 15.2 times, then you put the 3 first for the cube root, and then it's a second function, so shift, and then you'll see this key, and then whatever number you have in, you know, for the p, and then equal. So for the first one, again, it's easy because it's 0 times anything is 0, so that one is going to be 0 right here. For the next one, we get 51.98, so I'll just put 52. Take it back. I accidentally put in a 40 because this looks like 40 on the right side, but it's actually 60, so I went back and fixed it, and it should be 59.5. For 120, it should be 74.97, so 75. And for the last one, it'd be 85.8, so 86. So now I'm going to go ahead and plot the points. Notice on the horizontal axis, they're going by, oops, sorry, I thought I had the pointer. It's going by 20s. Every tick mark is up by 20. Over here, every tick mark is up by 10. Okay, so 0, 0, 60, I'll call it 60, 60, 60. So it's going to be 60, 60. And then 120, 75. So about here. And then 180, 86. So about here. Okay. Now this is a cube root function, right? So, but notice how they only show the positive side. They don't show, because cube root, remember, looks like this, like that, where it goes like this. But because this is a real world application, we can ignore the negative side. So that's why you only see the quadrant 1 on the screen here. Okay, so let's go ahead and connect the points like that. Okay, so for the next part, they want you to calculate the average rate of change right here, average rate of change for the intervals, for this interval, and this interval. So let's do the, let me move it up a little bit. Let's see, the 0 to 60. So you're going to go from 0 to 60, so we start off, and I'm going to use 60 instead of 59.5 right here. I'm going to use 60, so I'm going to do 60 minus 0 over 60 minus 0, so that's 1. And then from 60 to 120, I'm going to use these 2 points right here, these two. So it's going to be 75 minus 60 over 120 minus 60. So that gives me, what is it, it's 15 over 60. So that's 1531/4, so 0.25. And then the next interval, 120 to 180.